Okay. So one question, I just want to make sure, does everybody have access to MATLAB? Okay, you guys should have gotten an email from at the beginning of the semester. I might have done it like on the second or third day of class or something, but you guys should have an email from MathWorks, okay, or from the college, okay? If you don't have access to that, please let me know as soon as possible, okay? So
I have my own MATLAB software. Is that okay?
absolutely.
It's a newer version. I don't know if that's okay.
If you have a version from literally 15 years ago, that's fine. Okay, there's like the stuff that we're doing is pretty low level compared to what MATLAB can do. So if you guys have an older version, you should be good to go. If you do have some issues with it, just let me know and I'll try to help you with the update of that. Okay. All right. So what you want to do is you want to just open up MATLAB. And I know the large majority of you guys have used MATLAB before, but I'm just going to assume for the sake of the video that people haven't. But one of the first things you guys should do is when you open it up, you should get to a screen that looks like this, okay, the very first time, okay? What I'm going to do is to start a new script, okay? By the way, all these things shouldn't be there. This is just stuff that I graded from other classes, all right? What you want to do is you always want to click on this new script up here, okay? And it'll go ahead and it'll open up a new script for you. I often have students that type everything in down in the command window. Don't do that. Type it in up here, okay? Literally, folks, all you're going to do is you're just going to type in commands, and there is a list of commands on my Blackboard page, and let me show you where that is, okay? If you go into Blackboard, and if you go under where it says MATLAB assignments and help files, I click on this a lot, this quick sheet of MATLAB commands, and this literally tells you all the functions for MATLAB in like one shot, okay? At least like the really basic ones, okay? So that might be a good place for you guys to start if you've never used MATLAB or if you've never programmed, okay?
Is that where it is? College information.
It's what you want to do is you want to go to where it says MATLAB assignments and help files. No problem. And then it's where it says quick sheet. For those of you guys that want to do some more intensive stuff with MATLAB, here's a longer list of commands, but this one will do fine for what we need to do in this class, okay? So let's say, for instance, I want to evaluate something really simplistic, and let me show you guys how to do that, okay? So let's say I want to evaluate something like the third root of 9 plus natural log of 22 minus the sine of 12, okay? Now, if anybody in this class knows that off the top of their heads, please let me know how you got that, okay? Because I'm really interested. I got no clue. But what I'm going to do is I'm just going to type it in, okay? You guys know from like Calc 1 that what you can do is you can rewrite 9 as 9 to the 1/3, all right? So if you ever have like a third root or something like that, they do have an nth root function. It doesn't always work, okay? I don't know why, all right? On my version, it doesn't always work. So I just use the rational exponent. So I'm just going to go ahead and say 9 raised, parenthesis 1/3, plus log of 22. So in MATLAB, ln is log, and then minus sine of 12. Okay, so minus sine 12. Right? And then when you're ready to execute something, go to editor. Okay, so you might be on the home tab. You want to go over here to editor, and you just want to click on run. Okay, it'll ask you to save it. Okay, don't make the file name complex. Okay, when I ask you guys to submit the files, I ask you just to use your initials and then 1 or 2 or 3, depending on the assignment. If you do anything that has like ampersand or tilde, it's not going to run. Okay, MATLAB's actually pretty low level with the file names. Okay, I'm going to save it. It's going to run, and there's the output. Okay. If you ever want to format the output, and this is what I'm going to ask you guys to do for the assignment, I'm going to ask you to get it to 6 decimal places. What I'm going to do is I'm going to assign this to a variable a. So I'm going to say a equals. I'm going to put a semicolon at the very end here. Okay. For those of you guys that have used MATLAB before, what does a semicolon do at the end of a statement? So, Josh?
It stops it from running.
It stops it from printing to the screen. Right. Exactly. For those of you guys that are comp sci majors, there's something called echo output where it runs it, it prints it out, and then it prints it out again. Okay, because we're going to do a print statement. Okay, but if you don't want it to print twice, you just use a semicolon. The command I'm going to use is fprintf. Okay, and then I'm going to say the answer is, and then I'm going to say 0.6f / n, comma a. All right, there's a lot to unpack here. So if you give me them, I'll let you guys digest that, and then I'll kind of talk about what that actually means. Okay. And again, I know the large majority of you have done this before, but for those of you guys that haven't, I just want to make sure you're good with this. Okay. So first of all, the percent 0.6f, that means that I'm anticipating a variable. Okay, so that means that I'm going to print something out. That's going to be this variable a right here. 0.6 is the number of decimals. F is floating point in MATLAB. For those of you guys that have done computer science, what does floating point mean? Or what's an easy way of thinking of floating point?
It can be used again and again. It's a floater. That's probably not the best definition.
That's okay. It's decimal values, okay? So basically percent F means I'm expecting decimals. Percent D in MATLAB is integer values. And I'll show you the difference between those. There's only 3 you really need. And I'm going to show you guys these throughout the semester. There's percent F, which is going to use the most time. Percent D is integer. Percent S is string. Okay, everything else doesn't really matter that much to me. All right, now let me run. Oh, and one other thing. What does the / n do? Goes to a new line, right? It's the enter key, right? It's the return carrier, if you would. I'm going to execute this, all right? And then it tells us right there, the answer is to 6 decimal places. If I wanted it to 22 decimal places, I just type in 0.22. Unnecessary, but we can do it. I think MATLAB breaks around 40. So let me go ahead and type in 56. And what'll happen is MATLAB, oh, it's actually more than that. It looks like it's 50 decimal places. So I don't know if you guys can see it. I know it's tough to see down there, but let's see if I can, oh, that doesn't help much. But notice MATLAB has a pretty good precision of almost 50 decimal places. All right. What does the TI have? Like 9 or something like that? So this is certainly more precise than your TI calculator. Even though your TI calculator does it, it doesn't print it to the screen. Okay. All right. If I wanted to try to compute something, let me just do one more, and then I'll get on to doing graphs. All right. So let's say I had e to the 12th minus 2 to the 10th plus, let's say, log base 7 of 250. Okay. And let me just throw in one more thing for fun. Let's say plus arc sine of 13. Actually, let me do arc sine of 0.3. Just because I know arc sine has domain and range restrictions, I want to use a number that's between the domain for that. All right. So I'm going to do the exact same thing where I'm going to assign this to a different variable. Okay, let me assign it to b, just because I can. So I'm going to say b equals, we have our e to the 12th. I'm going to use exp12. Okay, so a lot of times in computer programming, and we've done this with Wolfram Alpha, right, where I've used exp instead of e. So that should be okay with you guys. Minus 2 to the 10th, that's easy. When I want to do this log, okay, MATLAB's a little bit stingy when it comes to logs. So here's what I do, folks. I just do the change of base formula, and I make this log 250 divided by log 7. Okay, I know it's been a long time since pre-calc, and you guys might have seen that like once or twice in pre-calc. But there's a formula that says if you want to go ahead and change, if you have an odd base, you could just change it to this, and it's the same thing. That's the way I do it, just to make it really easy. Okay, so I'm just going to say plus log 250 divided by log 7, and it doesn't matter what log you use. I'm just using ln. Okay. And then finally, for arc sine of 0.3, I'm going to say plus a sine 0.3. Okay. So in MATLAB, a sine, a tan, a cos are all the arc functions. Right? I'm going to suppress this and then check this out. I'm going to copy and paste that last line that I had. And I'm just going to move it down here. Then I'm going to change the a to a b. All right. So once you program one of the print statements, just copy it. Okay. No need to do the same thing. Okay. All right. I'm going to go ahead and execute this. And I should change this to 6 just because this is overly gratuitous. Okay. And there we go. We get our answers down here. Okay, so nice and neatly formatted, nice and easy to see. Okay, a command that I like to start with, okay, and I didn't do it at first because I wanted to show you guys like the actual output. I like to do this. I like to CLC at the beginning, and then I like to clear all. Okay, for those of you guys that have used MATLAB and seen these commands before, does anybody know what CLC does?
The command.
Clears the command window. Okay, so and then clear all. See all these variables over here in the workspace, A, ants, and B. I know these are tough to see. Like there's no way, like Gio, I know you can't see it back there, but just trust me, it says A, ants, and B.
Right.
But oh, you can see it. Good for you. Oh, that's right. You're an athlete. You can see everything. So good for you. But guys, these are actually the numbers stored in those variables. Okay, so it's actually pretty cool that MATLAB tells you what's in each of those. Clear all is going to make sure that there's nothing stored in those variables when the program runs. Okay, a lot of higher order languages, especially MATLAB, they remember variables from a long time ago, and if you don't clear it, it could use variable stuff. Okay, so anyway, so this is what I get when I run it. Okay, so all the other stuff going away, and now I have this. Okay, all right, folks. Any questions about basic commands in MATLAB? Okay, really easy. Go ahead.
Why does MATLAB like yell at you? You say all. It doesn't like it.
I know, and I think it's for an efficiency purpose. Okay, MATLAB was more programmed by mathematicians than it was computer programmers. Computer scientists, and I was speaking for all computer scientists, but computer scientists understand that memory is pretty nowadays. That memory is going to be pretty fluid. There's a lot of it, but back when MATLAB was created in 1983. I don't think anybody was born in here. Well, maybe one person.
20 years before that.
Jesus. Anyway, sorry.
Sorry. I'm proud of my age.
Good for you. Good thing I'm not recording this, right? But the all basically when it was never updated. It just means that it's going to run more memory than necessary. That's all. All right. We really don't care. All right. Nowadays. Okay. All right. Other questions, guys. All right. Let me show you guys how to plot stuff in MATLAB. Okay, if I want to plot, let's say a really basic function, okay, let's just say like I want to plot the arctangent function, okay, so I want to plot f of x equals arctan of x, and I want to plot that over, let's say, minus 3 pi to 3 pi, okay. I'm going to do it without this domain first. And then I'm going to do it with the domain, just to show you guys the difference between the graphs. It's not much, okay? Here's the way I do it, folks, and you guys might have a different way. I like to define a symbolic variable. So I'm going to define simsx, because then I can use a function called easyplot, okay? Easyplot makes things easy, okay? Then what I'm going to do is I'm going to say f is equal to a tan x, and I'm going to suppress that because I really don't care about the function itself. And then I'm going to go ahead and easy plot f. Also, what I'm going to do is right before the easy plot function, I'm going to type figure parenthesis 1, and I'll explain what all that does in a moment. Okay. Now, let me go ahead and execute this. And for those of you guys that have ever made plots using MATLAB, it does take a minute to compute the plot. All right, so just be patient. All right, but there it is. There's our arctangent function. Looks like the same one that I did in pre-calculus. Okay. Does anybody know what the domain is for default for easyplot in MATLAB, just for giggles? It's negative 2 pi to 2 pi. All right, so when you default something in MATLAB, like if you just use the plot function or whatever, if you don't define a domain, it goes from negative 2 pi to 2 pi. That's a pretty good domain, by the way. It gives a pretty good image. Now, if I want to fix that domain, what I'm going to do is in the easyplot function, I'm going to do comma, parenthesis, minus 3 times pi, comma, 3 times pi. Okay. Now, let me go ahead and execute that. Same graph, right, guys? Except it's like a little more stretched out. Okay. That's just because we changed the domain of that. Okay.
What does sims do again?
Sims makes a symbolic variable for x, which basically means now I can do a whole bunch of algebraic and easier operations. Okay. How many of you guys have ever seen this sort of thing where you define x is equal to 0:0.01:5 or something like that, where you make it a row vector and then you plot it based on that. That's another way to do it. But why bother doing that if you could just use the easy plot and it does it prettier? Okay, so that's another way to do it, but I'm just going to use it like this. Okay. One other thing that's the figure, by the way, that actually tells you which tab over here you're going to go to. So for instance, if I did a figure 2, let's say I let g be equal to x squared, and I'm going to do a figure 2, and then I'm going to easy plot g this time instead of f, and let's do it just because I can from, let's say, -2 to 2. So let me go ahead and run that, and I'll show you what that does. And I promise we will get to some differential equations using MATLAB in a few moments, but I want to make sure we have a good foundation for the other stuff. Check this up here, folks. We get a figure 1 and a figure 2. Okay. What happens if you don't use this figure command in MATLAB? What happens? Anybody know?
Then keep making it.
It'll overwrite all the graphs. So in fact, let me show you what happens. I'm going to get rid of these and run it. And let me close these out. Let me run it again, sorry. The eternal wait. Notice that figure 1 is now the quadratic, right? What MATLAB did was it actually printed the arctangent, but then it overwrote it, okay? MATLAB doesn't know that you want 2 different graphs, okay? So if I do this and this, now MATLAB says, oh, I know what you want now. I want to see both of the graphs, okay? Some of you guys know that you can also go through and you can kind of label the graphs as well. So one of the things I like to do is I like to put the grid on, not gid, but grid, okay? I also like to label the axes. So X label, I'm going to call that X-axis. Okay. So notice I just put those in apostrophes, and I'll say X-axis, not A-axis. And then Y label, I'm going to say Y-axis. And then finally, I can give the chart a title. Okay, so I can say title, and my title is entitled, so might as well be. All right, and then I'm going to note what happens to the first graph versus the second plot. All right, so just give it a minute, half a minute or so. This graph's a lot, oh, not this one, but this graph's a lot nicer now, right, folks? Because now we have axes in a grid, and then we have labels on here, okay? For you guys in your chemistry classes or your engineering classes, if you want to make a really nice graph, MATLAB does great for you guys, okay? You can save this file too, okay? So right up here, there's like these icons. You can just download this file, and you can make it a PNG or a JPEG or a PDF or something like that, okay? So you can just import those into a Word doc, okay? I do this all the time when I'm writing research or something like that. I just go ahead and take those graphs and move them in. Okay. All right, folks. Any questions about graphing? Any questions about labeling the graphs and titling them? Okay, pretty easy, right, guys? Not too bad. Okay. Now, one of the really cool recent features of MATLAB is the symbolic functions. And you guys can do all kinds of algebra stuff, all kinds of calculus stuff in MATLAB. Okay. So I want to show you guys how to do some of that algebraic stuff in MATLAB. All right. First of all, folks, let me show you guys how you can use MATLAB to simplify an algebraic expression. All right, so let's say I have this expression, like 2x plus 5y minus 3z plus 12 minus, this marker's dead, sorry marker, he's going to the graveyard, minus 3x plus 12y minus 7z plus 55. Now, I know we could all do that, okay? That's this would be a dumb problem for us to do in MATLAB, but let's just say, for instance, we had a whole bunch of these, okay? So what you would want to do first is you would want to say sims xyz. You want to define any variables as symbolic. By the way, folks, it never hurts to define a variable as symbolic, okay? So even like on this very first problem, if I defined a and b to be symbolic, it wouldn't have done anything bad, okay? Go ahead, sir.
So if you define x twice as a symbolic,
Yeah, it's fine. Okay, so so for instance, what I'm doing is I'm just redefining it as symbolic. It's not going to do anything bad to it. Okay.
Okay.
If I wanted to, up here, I could have sims x, y, and z And I wouldn't have had to do it twice, okay?
What does that mean when it's symbolic? What is that? I'm sorry to. do
That's
this.
okay. And do you mind giving me like 3 minutes and
Yeah,
I'll show
sure,
you the
sure, I'm
difference?
sorry.
No, that's okay. It's a good question because some people don't know and I want to make sure you guys understand. Okay. So let me go ahead and run this and then I'll show you what happens if you don't define it as symbolic. Okay, that might be helpful. I'm going to define, I'm just going to say expression is going to be equal to this animal up here. So parenthesis 2 times x. And for those of you guys that have multiplied in MATLAB, you know that you have to put the multiply there, right, guys? If you don't put multiply, it ain't working. Okay, so 2 times x plus 5 times y minus 3 times z plus 12, and then close parenthesis minus the quantity of 3 times x plus 12 times y minus 7 times z plus 55. All right, so we got it in there. I'm going to use a semicolon to suppress it. All right, I know it runs off the screen. Sorry about that. There you go. And then I'm just going to type in the command simplify expression. Okay, let me go ahead and execute that. And it's doing it in order. So what it's doing now is it's thinking about the graphs. And down here, here's our simplified expression, okay, at the very bottom. All right, I'm going to mute, by the way, these graphs in a second, all right? So that way we don't have to keep waiting because it does take a long time for the graphs. And I'm also going to show you guys how to format this output if you want to, okay? When you guys are doing the assignment, I don't care if you format the outputs or not. I can see what they are. But I know a number of you guys want to make sure you write the formats correctly, okay? So if you ever want to make code comment, so in other words, you don't want it to run, what you could do is you could highlight that code, and up here, there's this percent symbol. You could just hit that. So if you do a percent, the program's not going to actually compute that. It's just a comment, okay? Now, if I want to format this nicely, what I'm going to do is do an fprintf, and I'm going to say the expression is, and I'm going to say %s/n. %s is string type, okay? So remember we had %f, that was floating point. %s is string. And I'm going to say comma x, actually I have to assign this. So let me call this P. Okay, and I'm going to say comma P here. Okay. And then I will show you what happens if you remove the symbolic stuff. Okay, so I haven't forgotten that, but all right, so let me go ahead and execute this. Okay, and there it is. Okay, so really nice and good looking output there. Okay, look at let's
So what will happen if I didn't use the %s?
Gotcha. So let's say we use %f instead. Okay. Error. Okay. Yeah, it's going to tell you it can't convert it from double to symbolic. Okay. So you have to use your %s for this one. Okay. All right. Now let me get rid of the symbolic variables. Okay. And I know that x was symbol up here. I got rid of it. So I'm going to execute this. And MATLAB can't do it because it's an unrecognized function, okay? So basically, whenever we have sims, it makes it so that it can do algebraic operations. That's what symbolic means, okay? So does that help out a little bit to see like why we do that? Okay.
So the difference is like a symbolic is just x, but the other one is like x equals something.
Yeah, so that's just assignment. And you can let x be anything, but you can't manipulate it.
Yeah.
When you define it as symbolic, then you can manipulate it. Okay, you could do algebraic stuff.
Equation.
Correct, right. Okay. All right. So does that make sense, folks, as to how to do these algebraic operations? I'm going to do a lot more for you guys. Okay. I can factor stuff in MATLAB. Okay. So let's say for some reason I want to factor something like x cubed minus 5x squared minus 6x. And I want to break that down into its discrete factors. Okay, what I'm going to do is I'm going to say q is equal to our x cubed minus 5x squared. So remember 5 times x squared minus 6 times x. I'm going to suppress that. And then I'm going to go ahead and say, I'm going to call it t, and t is equal to factor q. Okay, so I just use the command factor. And then I can just cheat up here, copy and paste that, and say the factored expression And it doesn't matter what you put in those quotes, okay? Now I'm going to change this from P to T because I want to make sure I'm printing T out instead, okay? And let me go ahead and execute that. All right, now I want you to notice what it does is it prints out three things, okay? So it prints out x, x plus 1, and x minus 6. Because T is now an array, because there's more than one factor, it stores it in T1, T2, and T3. So for those of you guys that want to know, like, this is like T1, I'm going to go ahead and execute that and show you what happens with T1. T1 is just x. T2, that's the second element in the array of T. T2 is x plus 1. And then surprisingly, T3 is going to be that x minus 6. They're all here though, right? Here's the x minus 6, etc. So it might be easier for you guys when you run this to not have that expression and just do T equals factor Q and check out what it does. It just writes it in an array, okay? So you can see what the factors are. That's probably the easiest thing to do, okay? There is a way, like if you want to use a for loop or if you want to use like an I equals 1 to 3, you can do it that way, all right? But I'm not going to ask you guys to do anything fancy with that, okay? All right, if I want to simplify a rational expression, so let's say I had x cubed minus 5x squared minus 6x divided by x cubed minus x squared. And I want to simplify that rational expression. What I'm going to do first is I'm going to give that rational expression a variable. Okay, so I'm going to assign it to, let's say, we've already used a, we can reuse it. So a is equal to this expression. And then I'm going to divide that by our x cubed minus x squared. Okay. Then what I'm going to do is I'm going to use the simplify function. So I'm going to say simplify a. Okay. I'm going to go ahead and execute this. All right, and there it goes. It factors it down and it cancels out the common factors for you. Okay. So pretty neat. I mean, if you ever have like one of those nasty rational expressions in another class and you can't simplify it, MATLAB might be able to do it. Or you could just show that it can't be simplified. Okay. All right. If you want to solve an equation, okay. Let's say, for instance, I want to solve x cubed minus 5x squared minus 6x equals 0. Okay. What I can do is I could just go ahead and make an equation. So I'm going to say EQU is going to be equal to this. All right. There's one caveat. Okay. So x cubed minus 5x squared minus 6x. And instead of equal 0, you have to use double equal 0. Okay. In MATLAB, a single equal is assignment. Okay. So you're telling it it's going to be a variable. Double equal is it should solve something, or there's a Boolean test. Okay. For any of you guys that have ever heard the phrase Boolean, it's if it's 1 or 0, it's yes or no. It's basically testing where is this equal to 0. Okay. Then what I'm going to do is I'm going to solve the equation. So I'm going to solve EQU comma x. Okay, so I'm going to solve that equation for the variable x. I'm going to go ahead and execute it, and it's going to give me my 3 solutions. Okay. Notice it spits it out as an array. All right, and that's okay. Most of the time, we don't care what it looks like. We just care that it gives us the answers. Okay. All right. So any questions about algebraic operations? And now you guys just learned pre-calculus pretty much in 20 minutes. Okay. All right. MATLAB can also do calculus stuff. Okay. So if you want to do a limit in MATLAB, like for instance, earlier in the course, we saw stuff like this, like the limit as t approaches, or I'll just say x approaches infinity, of something like 50 plus 20e to the minus x over 2, right? And we saw stuff like that, okay? If I want to do that in MATLAB, I just use the limit function, okay? So let me go ahead and first define the function. I'm going to set that equal to p. So I'm going to say p equals this expression right here. So 50 plus 20 times exp to the minus x over 2. And then I'm going to take the limit of p, okay? And then I want the limit of p, the variables x, and then I'm going towards infinity, which in MATLAB is I and f, okay? And of course, when we evaluate this limit, shouldn't this limit be 50? Because this thing goes to 0, right? The 20e to the minus x over 2. So we know the answer should be 50, but let's see if MATLAB, oh, by the way, this should be a plus, right, guys? I think I typed in a times sign there, okay? So let me go ahead and execute this. Okay, and there's our limit right here is 50, okay? So limit command's really nice. You could just go ahead and find the limit, okay? So now the first 3 or 4 weeks of Calc 1, you just learned how to do, all right? We can take derivatives in MATLAB, okay? If you want to take the derivative of this animal, okay, so ddx of x to the x, okay? That's one of those that we very rarely take the derivative of, right, guys? We don't see this function too often, but it's a pretty nasty one to find the derivative of, okay? Most of us have probably forgotten, or we just never did that one in Calc 1, okay? If you're interested in seeing how to do it, I can show you after class. But I would define f to be x to the x, and then I'm just going to use the function diff f, okay? And then comma x. That's going to tell us which function or which variable to take the derivative with respect to, okay? For those of you guys that are suffering through Calc 3 right now, you just learned today how to do a partial derivative. So if you wanted to learn how to take the derivative with respect to y, you could just change that to a y, okay? Now I'm going to execute this just to show you what the derivative is. All right, and it's this nasty representation, x times x to the x minus 1 plus x to the x ln x, okay? Again, if you're interested in seeing why that is, I'll show you after class. It's a pretty fun way to do it, but I could take a derivative of any function. If I take it with respect to y, it's going to be 0, right, folks? Yeah, because it'll treat it like a constant. Good. Okay, and there it is, right there. Okay. So for those of you guys that are taking Calc 3 and you're just learning partial derivatives, this is a way to check your partial derivatives, right, guys? Okay, you can make up a bunch of problems for yourself. All right. Even better, integrals, okay? For those of you guys working on assignment 8, you guys probably have noticed that some of the integrals are, what's the best way of putting it? Not so nice, okay? There's other phrases that you guys could use. Well, since we're being recorded, we won't say those. But let's say, for instance, perhaps I want to evaluate this integral. Maybe something like 2/3 x plus 1 e to the 3/2 x for some reason. I want to integrate this with respect to x, okay? By hand, that's an integration by parts problem, right, folks? Okay, it's not a terrible one, but there's things that we'd rather be doing than taking the integral of that. So what I could say is I'm going to let p be equal to 2/3 times quantity x plus 1 times exp of 3/2 times x. Okay, so that's my integrand. Then I'm just going to say int p comma x. I'm going to go ahead and execute this. And there's our integral. Okay. Probably would have taken us, what, like 5 minutes to do that. MATLAB took us, what, like 30 seconds to type it in and do it. Okay, so congratulations. I just taught you guys half of Calc 2. Okay, we're just moving through our calculus series. Okay, so does that make sense, folks, as to how to do like a lot of these operations? Check this, folks. If I wanted to do this, put some limits of integration on there. Okay, what I would do is I would just add a third and fourth parameter. So I would say comma 0, comma 1. Okay, I think for homework I only ask you guys to do the integral. All right, but I'm going to go ahead and run it. It's going to give us like something symbolic. Okay, there you go. All right. If you want to approximate that, you can assign it to a variable, and then you can just do the fprintf statement with the %.6. Okay. Most of us, if we look at this, we don't know what that's approximately. Okay, so we probably want to get like an fprintf and try to get some sort of approximation for it. So I might do something like q equals this. and I might do like f print f, okay, the approximate value is %.6f /n, comma, q. Okay, so basically the exact same thing that we did before with the f print f. Okay, so I'm going to run it. I'm just curious to see what the approximate value is. Okay, 2.508. Okay, so there we go. It's a lot less interesting than I thought it would be. All right, so folks, any questions I can answer about the basic stuff before we actually start doing differential equations in MATLAB? All right, folks, on the assignment, before I get to the last couple questions, oh, I had it. It ran away. It ran away again. Why do I have the quiz up from the last class? There it is. I just want to make sure we went through everything so far before we get to the differential equation stuff. So, everybody feel good about doing 1 through 3? All right, we went through, we did this, like all the computation stuff. We plotted some functions, and then I showed you guys how to factor, solve, simplify, find a derivative, find an integral. Okay, so basically, guys, if you watch this video, you can just go through the syntax again. Okay. All right, now the other stuff that I'm going to show you guys how to do in MATLAB, I'm going to show you guys how to solve differentials, and then I'm going to also show you guys how to get the slope fields and plot the solution on the slope field. I know we've done this using Wolfram Alpha, and we've also used Desmos to do that, right, folks? But I want to show you guys how to do it on your own, okay? Because maybe you want to manipulate that graph, okay? So let's say for some reason, I want to solve, excuse me. This is a differential equation we've looked at a number of times in class. Okay. So let's say for some reason I just want to solve that differential equation in MATLAB. Okay. And then I'll show you guys how to do initial value problems and stuff like that in a moment. Okay. So first things first, I'm going to clear all this stuff out. Okay, because we really don't need it. I'll do a CLC and I'll do a clear all. By the way, when you're writing your programs, guys, you don't need multiple CLCs and clear alls. You just need one. Okay. So CLC, clear all. Okay. I'm going to define some symbolic variables. Okay, so I'm going to define x and y at x. Okay, so it's a little bit different. I'm going to make my differential equation equal to y prime. Okay, so the first thing you guys want to do, you might have to do this by hand, but you're going to say that y prime equals x minus y. Okay, so you basically want to isolate whatever the differential is. Okay. It makes it a little easier. You don't always have to do that. Okay, I'll show you guys an example of not doing that. And what I'm going to do is I'm going to say diff y comma x. Okay, so that's this y prime. And let me call that EQU. So I'm going to say EQU equals diff yx double equals x minus y. Okay, so that's my differential equation. Then what I'm going to do is I'm going to use this command, dsolve, and I'm going to dsolve EQU. Okay. And let me just go ahead and execute that and show you guys what you get out of that. All right. There you go. Okay. It just takes and solves a linear differential equation for you. Okay. So realistically, guys, to solve a differential equation, you need 3 lines of code in MATLAB. Okay. Pretty easy, right, guys? Okay. Now, we know that we've done initial value problems. So let's say, for instance, I'm going to throw in a little extra here that y at 1 is equal to 2. Okay. What I'm going to do is I'm going to assign that to a variable, and then I'm going to include it in the dsolve function. Okay. So I'm going to say COND is going to be equal to y at 1 double equals 2. Okay, so same thing that we've done before when we're solving or we're signing. We use a double equal. Okay, so y at 1 equals 2. And the other change I'm going to do is down here in the dsolve function, I'm going to say EQU, comma, COND. Okay, I'm going to execute. Right, and there we go. We get the particular solution for that. Okay. All right, so folks, these 4 lines of code can solve a lot of elementary first order differential equations. MATLAB can't solve everything though. Okay, so I want you guys to know that, remember we did some equations by substitution and Bernoulli equations and exact equations. A lot of times MATLAB can't handle those, okay? So just be aware that this doesn't work all the time, okay? The ones I'm going to give you guys, they'll work, okay? A lot of times, guys, if you can solve them by hand, MATLAB will do it for like linear and separable equations, but not the other types. So that's why we have to know how to solve them by hand, okay? All right, now that's for first order differential equations, okay? What if I wanted to solve something like this? Maybe something like y double prime plus 2y prime plus y equals e to the x over 1 plus x squared. Okay. In fact, let me make this a minus. I don't know if it matters or not. So I'll just do that. Okay. In fact, I think this was this one of the problems that we did on Monday or close to it, right, guys? Because we got like an arctan and we had to use. Was it a minus there? Okay. Thanks.
Either one or the other.
Yeah, I think it was a minus. So let's give it a shot and see what happens. It was that, Zach. Okay, thanks. All right. So let me just show you guys how to program that. All right. Now, what we're going to do is we're still going to use EQU. I'm going to say diff y comma x comma 2. That's the second derivative. Okay. So whenever I want the second derivative, I use diff y comma x comma 2 minus 2 times the first derivative, diff y comma x. Okay. And then finally, plus y. So I'm just going to say plus y double equals exp x divided by quantity x squared plus 1. Okay. All right. So really, folks, the only difference is this guy right here, right? Then what I'm going to do is I'm going to do a desolve EQU. Okay. Now this is just going to give us a general solution. I do have a particular solution that I'll show you folks in a moment. Okay. So let me execute that. All right. And there we go. This should be familiar to the equation that we got on, or the solution that we got on Monday. Okay. A little bit uglier. Okay. But you guys might remember that we got like a natural log in there because we had to do a U sub. And then we got an arctan. Okay. So it looks like the solution that we get from here is pretty close to what we got on Monday. Okay. All right. Now, let's say for some reason I want to do an initial value. Okay. So let's say I have y at 0 is 1 and y prime at 0 is 1. Okay. So here's what I'm going to do with that. Okay. I'm going to define a new variable. I'm just going to call it dy. And I'm going to call that diff of x or y comma x. Okay. Now I need this because when I get this second condition here, I'm going to play dy at 0 equals 1. Okay. For my second condition. Okay. Now it's a little sneaky. So I'm going to say condition 1, because I have 2 conditions, is going to be y at 0 double equals 1. Okay, so that's going to be that first condition right here. Okay. My second condition, I'm going to call that cond 2. That's going to be equal to dy at 0 double equal 1. Okay, so that's why we needed dy to be the derivative. And what we're doing is we're just substituting 0 back into the derivative there. Okay. I'm going to make one more variable. I'm going to call it cons. And cons is going to be equal to an array of cond 1. And I think it's comma, or it's cond 1, cond 2. All right. And I'm going to put a semicolon there. All right. So does this, first of all, do these 4 lines make sense to everybody? This is the derivative right here. We need that for condition 2. Okay. This cons is just these in a single variable. Okay. That's how MATLAB stores it. It's just a single array with a space between them. Down here in the desolve, I'm going to say comma cons. Okay. So it's a little bit of a pain to get that second order differential in there, but could be worse. Okay. There we go. That's going to be the particular solution to this. Okay. All right. If I really wanted to, I could assign that to a variable and get a really nice printf statement as well. Okay, so for instance, I'll just do it. I'll say, let's let p be equal to this. And I'm going to do an printf. And I'm going to say the solution to, I'm going to say the DE is %s/n, and I'm going to say comma p. Okay, and it should print it out really nicely for us. Okay, so there it is. Solution to the DE is this thing. All right, like I said, I don't really care that much about this, but for those of you guys that are going on and your teacher does care about the format, okay? And I'm guessing a large majority of you guys are going to either UMBC, UMD, Delaware, York, Towson, places like that. They probably want you guys to format it really nicely, okay? Just because, so. All right. So does that make sense, guys, how to solve first and second order differential equations? Okay. So now I've just taught you everything that we've done for the first 4 weeks of class. Okay. So now you guys can do Calc 1, Calc 2, Calc 3, and differential equations in MATLAB. Okay. Would have been nice if somebody would have showed you this and you would have saved 3 semesters of your life. Okay. But the good news is now you actually know how to do the stuff. All right. The other thing I wanted to show you folks is how to get a direction field. Okay. Now, and also to plot a solution on a direction field. Okay. So this is actually pretty sneaky. Okay. Or kind of tough to do this. Okay. So I do want to make sure I'm kind of going from scratch with this. So I want you guys to take a look at this differential equation. Let's say we have y prime is equal to, let's say 2y over x squared. Okay. I know everybody in class can solve this. This is a really nice, easy, separable differential equation. Okay, if I wanted to. Okay, but what I want to do in MATLAB is I want to solve. Oh, and let's do this. Let's say y. I can't use 0 because 0 is not the domain of that function. But I think let's use y at 1 as 1. All right, just because I know it works. So let's solve. Okay, let's create a slope field. And then finally, the last thing we should do is let's go ahead and plot the solution on the slope field. Okay. I'm going to do this in sort of a reverse order, if you would. I'm actually going to create the slope field first, okay? Because that's something we haven't done. You guys know how to solve this, right? We just did that, okay? But I want to go ahead and create the slope field. Then I'll solve it, then I'll plot it on the slope field for you guys. All right, so like I said, the slope field is a little bit nasty, okay? But don't worry about it, it's not too bad, okay? I'm still going to maintain my symbolic variables that I had, except I'm going to add in one more variable that I'm going to call capital X, okay? Capital X is going to be different than lowercase x, okay? Because what I'm going to do is I'm going to use capital X to represent the variable in the solution. Okay. I'm going to use lowercase x as the domain for the slope field. Okay. So there's 2 different x's that I'm using. One of them is going to be for the domain. The other one's going to be for the actual solution. Okay, so what I'm going to do first is I'm going to create a domain for this. Okay, so basically, let me do like from -4 to or from 0 to 4 or something like that. So I'm going to use this x comma y is going to be equal to this mesh grid, and I'll show you what this does in a moment. Okay, so mesh grid 0 comma 0.02 0 colon 0.02 colon 4 0 colon let me use 0.2 instead. 0.22 is too small. Okay, so 0.0 0.24 0 0.2 and then 4 as well. All right, now I'm going to run this in a second just to show you what this does. This just makes a whole big array of numbers for x and y. So basically, it just makes a domain we can plot it. Okay, so let me run it. All right, and basically, we just get a whole bunch of numbers for X and Y. So these are a bunch of ordered pairs, okay? So I have the ordered pair 3, 8, 3, 8, 2, 2, and I get a whole bunch of these, okay? So realistically, folks, I'm just creating all those points on the slope field. That's what this command does, okay? Now, what I'm going to do at this point is I'm going to define what the differential equation is. So I'm going to call this y prime. And I'm going to set that equal to 2y. Now 2y, and I'm going to use dot divide. X dot square. Okay. For those of you guys that have ever used MATLAB, okay, why did I put a dot in there between some of those operations? Anybody remember? Or anybody know? I know maybe some of you guys have never seen it. Josh?
It has something to do with the syntax.
Exactly. Okay. In fact, because I've defined X to be an array right here, what I want to do is I want to square every element of X, and I want to divide every element of X in the array. Okay. Before I didn't have an array of values. Okay. So you're exactly right. We just want to make sure that we're operating on every element in the array. Okay. So for some of you guys that have used MATLAB before, there's matrix operations and there's scalar operations. Okay. A dot means you're doing a scalar operation. Okay. All right. So now that I have this, what I want to do is I want to start creating that vector field. Okay. I'm going to go ahead and create angles for my vectors. Okay. So let me go ahead and say that theta, this is going to be the angles that I'm going to create, is going to be equal to the arctan of y prime. Okay. Now you guys probably remember that the tan of theta is going to be equal to y over x, right? That's like a long-standing definition from trigonometry. If I want to find the angle, that's the arctan of y over x. And that's exactly what I'm doing, is I've got a bunch of x and y coordinates right here, right? And I'm getting the angle of every single one of those, okay? So for those of you guys that really want to know what this is doing, I'm just finding a bunch of angles. That's all I'm doing, okay? Now, I'm going to define, to find the x coordinate and the y coordinate, I'm going to call u, that's going to be equal to the cos of theta. And then I'm going to let v be equal to the sine of theta. Okay. All right. Now, last thing I want to do before I actually start plotting the function, or I'm sorry, plot the function on the field, I'm going to use this function called quiver. Okay, so I can get like figure 3, because remember we had figure 1, figure 2, this is figure 3, and I'm going to use quiver. Okay, this is the only way that I know to plot a vector in MATLAB. Okay, using vector quiver, and I'm going to say x comma y. Okay, so that's going to be the domain with which I want that vector field to look like. And then the angles I'm going to plot are going to be u comma v. Okay, so x comma y is the total domain. U and v is going to be all of the vectors and the angles of those. Okay, so let me go ahead and plot this now, just to show you guys what happens. Hopefully this works. Otherwise, I've just wasted 10 minutes of your life. Okay, there we go. This is the slope field of this differential equation. Okay, now check this out, folks. If I change this, bless you, Chris, if I change this from 0.2 to 0.4, I just want to show you what this does. Yeah, in fact, we're creating less numbers, right? Because there's, yeah. And when I run this, watch the slope field. Arrows get bigger, right, guys? There's a fine line between having too few and too many arrows, right, guys? Because too many, let me do this. It might take a minute to run. Let me do 0.01. What do you think is going to happen if I change it to 0.01? Yeah, it's just going to be a mess, right? It's just going to be a plot of nothingness. It's going to be dense. And it might take a moment to do it because there's so many values. It's crunching, it's crunching, it's crunching, it's crunching, it's crunching. I think I broke it. We'll give it another 10 seconds, just out of courtesy. Come on, MATLAB, let's go. If I yell at it, it might work. I might have broken it. Go ahead.
So essentially with that those line of code there, you created a matrix of X and Y values. You wrote the equation for Y prime, you solved for theta from Y prime.
And these are the angles of those vectors, right?
Yes.
That's the x coordinate, that's the y coordinate now of the initial and terminal points. Right. So basically what we're doing is if we have our slope field, right? At this point, it's telling us the terminal point for that vector, okay? And so x and y is the initial point, u and v is the terminal point because it's the cosine and sine of that, okay? And we're just getting all those vectors, okay? MATLAB gave us a great vector field, by the way. Yeah, it's just a big old blob. So that's why I'm saying like back here, I usually find like 0.2 or 0.3 to be a pretty reasonably good estimator. But for those of you guys that have like a bigger domain, maybe 0.4, 0.5 might be good, okay? But that's a pretty good vector field, okay? We can get a pretty good idea of that. All right, now I want to go ahead and solve that equation. I'm going to do this in a different tab, okay? Because what I'm going to do is I'm going to solve the DE and I'm going to program it into the code, okay? So I'm going to have to CLC, I'm going to have to clear all. And remember, we have the sims x and y at x, okay? So this is the problem that we did just before this one. And what am I going to do? I'm going to first define the equation. So I'm going to say EQU equals, since we're doing a symbolic, we don't have to put the dots in there. So it's going to be 2y divided by x squared. I'm going to do my condition. So my condition is, what was it? Y at 1 is 1, I think, folks, right? And double equal. Okay. And then I'm going to desolve EQU comma con. Okay. Now this is in a completely different code. Okay. So I'm just getting the solution because I want to put that solution back into my other code. Okay. So let me go ahead and execute this. It's going to ask me to save it. I'll just save it as CJ123. All right. And error. Okay. So what did I do wrong? No differential. Oh, you know, it'd be it'd be helpful if I called this diff y of x. Sorry about that, folks. I forgot the actual derivative. Say double equals that, and say this equals. So sorry about that, folks. So completely forgot that to have a differential equation, you need a derivative. That's usually helpful. So just write that on my teacher evaluation. Clearly doesn't know the difference between nonlinear equations and differential equations. Good thing this isn't being recorded. How embarrassing. Okay. Here's our solution, friends. Okay. I'm going to write this solution because that's what I'm going to code into my solution. Okay. So I'm going to say that exp2 times exp minus 2x, right? That's our solution. Or 2 over x, sorry. All right. I'm only writing that down for my memory. So when I go to code this, okay, so check this out. This is actually pretty cool. And we're almost done, by the way. We have to be because we only have 15 minutes left. So what I'm going to do, folks, is I'm going to plot the solution, okay? And I'm going to call it solution. So let me go ahead, and it doesn't matter where you do it. I'm just going to do it right before the figure, and I'm going to say sol is equal to, we said exp of 2 times exp of negative 2 over capital X, okay? I'm going to make a note here. Use capital X for all X's. Okay. I also should make a note of learn how to spell. All right. But what I want you guys to notice is remember up here, we made a capital X as a variable. That's because I don't want to use this X coordinate. Okay. So this is the domain for our array to be able to create the vector field or the slope field. This X is just so I can plot it. Okay. What I'm going to do now is I'm just going to do this. I'm going to say, hold on. And I'm going to plot this solution. So I'm going to easy plot my solution, okay? And then I'm gonna plot it over the domain from 0 to 4. Okay, and again, 0 to 4 is because that's what I defined right here. Okay, last thing I'm going to do is I'm going to hold off. Okay, so once you know what the solution is, you just code the solution using a capital X, and then you go down here and do an easy plot. Okay, so let me go ahead and execute this for y'all. All right, there we go. All right, we get a really nice plot on our field. Okay. I can, if I really want to, I can kind of limit this stuff that's outside of the domain. So what I could also do is I can say 0 to 4, comma 0 to 4. What that'll do is this is the y coordinate. Okay, so this would be the range. This would be the domain. Okay, in an easy plot function. So let me run it again. It'll give us like a little bit nicer graph, but not much. Okay, I mean, this is a pretty nice graph. Okay, there we go. Okay. Clearly, we can see that this matches all those vectors in here, right, guys? If I plot any of those, which is really nice. Remember when we did it in Desmos? Desmos had really big vectors, right? And sometimes we didn't know if our answers were correct or not. MATLAB, we can make the vectors as large and small as we wanted. So if I went back up here and made these 0.4s just for fun, all right, this is probably about what Desmos would give us, right, guys? Something like this, okay? It's still good. There's nothing wrong with it. It's just not as good, okay? And so that's one of the benefits of using MATLAB versus Desmos is that we have more control over what the graph looks like. We're at the mercy of Desmos, right? Desmos tells us what to do. But with MATLAB, we tell it what to do, okay? And that's one of the great things about programming languages is that we get to tell the computer what to do, not the other way around, okay? All right, so does all this make sense? So let me take those away and show you what happens, sir. If I take those away and run this, I just get the plot of the function. Hold on and hold off. Make it so that this is the vector field and this is the function plotted on the same graph. So basically what you're doing is you're saying, okay, before you go to the next graph, hold on, plot this on the same graph. Then hold off means, okay, I'm done plotting stuff on the same graph, okay? And if I run it again, it gives us our solution up here. Worthless, but there we go. All right, so if I look at the assignment, just to make sure that this is okay with everybody, the last couple questions, okay, these are just solving a few differentials, right, guys? Okay, so we did this right beforehand, and then, oh boy, check this out. Have you guys seen that before? It's the exact same problem that we just did. So
This is recorded, right?
it is being recorded, right? So you guys can at least use this one as a practice. This one, obviously, we haven't done this one, so at least you get one exercise out of it. I don't know why I did the same problem, but oh well, whatever. Fun stuff. Okay, folks, any questions about MATLAB stuff before we conclude? I'm going to stop this video then.